Algebra 1 Mixed Review, Question 9. When solving for the value of x in the following equation, 4 times x minus 1 close parentheses plus 3 equals 18, Aaron wrote the following steps on the board. And he showed on line 1, 4 times x minus 1 plus close parentheses plus 3 equals 18. That's the original question. In line 2, Aaron went on to move that negative 3 to the other side by subtracting it. That's not explicitly written, but he would have subtracted 3 from both sides in order to get line 2. And then we notice how there are parentheses here. And when you have a number or a term in front of parentheses, you have to use the distributive property. So 4 times x would be 4x, but you also would have to multiply that number 4 by the other term in parentheses. 4 times negative 1, this should be a negative 4. So right there between step 2 and 3 we saw a mistake, and that was using the distributive property incorrectly. Another question on the distributive property: which of these shows distribution of multiplication over addition? So right here we have 6. We have to multiply that 6 by 3a, which would be 18a, so that's good so far. And then 6 has to be multiplied by a positive 4b, which would be a 24b. So right there, this one's out. Let's try choice B. 6 times 3a would be 18a, and then 6 times 4b would be 24b. That's the right answer. Right here, we have 6 times 3a plus 4b equals 3a plus 4b times 6. This property is the commutative property. They're changing the order of the factors, which doesn't change the product. So that's the commutative property. They wanted distributive. And then we have 6 times 3a plus 4b is equal to 6 times 4b plus 3a. If you're noticing, all that happened was the parentheses, the order of the add-ins was changed. So that would also be another case of the commutative property. They just switched the order in which they wrote the add-ins in the parentheses, which would not be the distributive property. 11, the reciprocal of 5. This is related to the negative exponent question. The reciprocal of 5 would be 1 over 5, so 1/5. And a way of checking that is that when you multiply the reciprocals, so when you take 5 and you multiply it by the reciprocal, it would equal 1. So an important note would be to write down that the product of two reciprocals always equals 1. Number 12, we're writing an algebraic expression. Which expression represents 5 less than twice x? The order matters here. 5 less than would imply that first you would multiply 2 by x, you would twice x, and then you would take off the 5 off of that. The order really matters here. The 5 is less than 2x, so the minus 5 should be after the 2x. 13. Mr. Stanton asked his students to write an algebraic expression. He chose 4 students to go to the board. Robert wrote, this would be an inequality since there's a greater than or equal to sign. So that's not what we're looking for. Meredith wrote 3y minus 7 plus 11z. I don't see an equal sign, so that could be the right answer. Let's check the other ones though. Stephen wrote 9w plus 2 equals 20. The minute that there's an equal sign, it becomes an equation. The same idea with Cynthia, there's an equal sign. 8 plus 10 minus 4 would equal 14. That's an equation. So we're going to go for Meredith. That's the algebraic expression out of those 4. 14. Josh and May work a concession stand. They each earn $8 per hour. However, Josh worked 3 hours more than May. That's an important piece of information here, because they're getting the same pay each hour, but Josh worked 3 hours more than May. So that means that Josh is going to make more money. However, they are interested in if Josh and May earn a total of $120 together, how many hours did he work? So what we're going to do here is we're going to let X represent. You always have to say what your variables represent. We're going to let X represent number of hours May works. And then we know that Josh worked 3 more hours, so we could just take the X that represents May's hours and add on 3 hours. So we're going to let X plus 3 represent number of hours. You always have to write this. Josh worked. Or worked. So if we add up their number of hours, so we're going to take X, which is the number of May's hours, and add it to X plus 3, which is the number of Josh's hours. This would be the total number of hours worked by them. They're talking about money, though. So remember how it's $8 an hour. So I'm going to bracket all this in with another set of parentheses. The sum of these hours has to be multiplied by the cost that they get per hour, the $8 fee, the $8 payment per hour. Take the $8 payment, multiply by the number of hours, and this should equal their total was said to be $120. What you have to do is add what's in parentheses. X plus X would be 2X plus 3, and there's the $8 for all those hours outside, and this equals 120. Since 8 is outside of parentheses, you have to use the distributive property. 8 times 2X is 16X. 8 times 3 would be plus 24, and this is equal to 120. I'll do 15 on loose leaf. So the next part would be that we now have 16X plus 24 is equal to 120. Take away 24 from both sides. That would be your first step. 16X is equal to 120 minus 24 would be 86. And the next step would be to use inverse operations and divide by 16 to get X alone. So X is equal to 6. And then you got to remember, what does X really represent? That means that May worked 6 hours. And you got to be careful here because they're not really asking about May. They're asking about how many hours Josh worked. So Josh is X plus 3 hours. So we're going to have to take our X value of 6 and add on 3 to get 9 hours. 9 hours is the answer that they're interested in. And I will work on the 15th one. We want to solve on loose leaf. Solve algebraically for X. We have 3 parentheses, which means 3 times X plus 1, close parentheses, minus 5X equals 12 minus parentheses 6X minus 7. We're going to take care of the left side first. Distribute the 3 to both terms in parentheses. 3 times X is 3X. 3 times 1 is plus 3. You have to take 5X off of that. Bring down the equal sign. And we're going to just bring down everything as is for the right side and finish with the left side first. Combine like terms. You have 3X and you have minus 5X. You can combine these like terms because they have the same variable and the same power. 3X minus 5X. 3 minus 5 is a negative 2, and the X comes with it, plus 3. These are unlike terms. Negative 2X plus 3 can't combine. They're unlike terms. Equals, let's take care of the right side now. On the right side, we're going to have 12. And now that minus sign is distributed to everything in parentheses. So minus 6X comes down, and it's going to be negative negative 7. A double negative is going to make that plus 7. Now over here on the right side, we can combine like terms in terms of the constants, because we have a constant 12 and a positive 7. Those can be combined. Bring down your left side and the equal sign. the 12 and the 7 can be combined to be a 19. The minus 6x comes down. And now we have the variable on both sides of the equation, so we have to remember what we have to do here. We have to move all of the variable terms to one side. I'm going to choose it to go to the left side, and all your constants to another side. I'm going to choose it to be the right side. Over here, I have a minus 6x. I really want it to be over here, so I have to use plus the opposite, the inverse operation. I have to add 6x to both sides. Negative 2x plus 6x would be a 4x. Negative 2 plus 6 is 4, and x is with it. Plus 3 is equal to 19. All my variables are on the left side, which is good. My variable terms are on the left side. I have to move all my constant terms to the right now. Take the 3 and move it to the other side by using inverse operations and subtract 3. 4x is equal to 16. And we finally get x alone by dividing by 4. X is